Imagine looking up at the night sky, countless stars, each a distant sun, some with their own planets. It's a breathtaking sight, a reminder of how vast and mysterious our universe truly is. Every twinkling point is a world of possibilities, and for centuries, humanity has gazed upward, wondering what lies beyond. For most of history, these were just mysterious points of light. Ancient civilizations created myths and legends to explain them, never knowing that some of those stars might host planets not so different from our own. But our closest stellar neighbor, Proxima Centauri, actually has a planet orbiting it, Proxima Centauri B. This discovery has transformed our understanding of the cosmos and our place within it. This is the closest exoplanet ever discovered, just 4.24 light-years away, a cosmic stone's throw. In the grand scale of the universe, it's practically in our backyard. Proxima Centauri is a faint red dwarf, part of the Alpha Centauri triple star system. It quietly orbits alongside its brighter siblings, Alpha Centauri A and B, forming a complex and fascinating stellar family. If you traveled in our fastest spacecraft, it would still take tens of thousands of years to get there, but in galactic terms, it's right next door. The sheer distance challenges our imagination, yet it also inspires dreams of interstellar travel. Red dwarfs like Proxima are the most common stars in the galaxy. Smaller, cooler, and dimmer than our sun, but they burn for trillions of years. Their longevity makes them intriguing targets in the search for life. This longevity could offer a stable environment for life to develop. Around such stars, planets have time to evolve, adapt, and perhaps even flourish. Orbiting this tiny star is Proxima B, a planet that has captured the world's imagination. It sits within the habitable zone where conditions might allow liquid water to exist. Its existence raises profound questions. Are we alone? Could there be other forms of life, waiting to be discovered just a few light-years away? Could life exist around a star so different from our sun? What would it look like and how would it survive in such an alien environment? Or could Proxima B one day become a new home for humanity? The idea of reaching out to another world is both daunting and exhilarating. The journey to answer these questions begins with understanding our closest planetary neighbor. Proxima Centauri B is more than just a distant world. It's a symbol of our curiosity, our hope, and our endless quest to explore the universe. Finding Proxima B wasn't as simple as snapping a photo. The planet orbits a faint star and emits no light of its own, like spotting a moth around a candle from miles away. Astronomers use the radial velocity, or wobble, method, watching for tiny shifts in Proxima Centauri's light as the planet tugs on it. Using the HARP spectrograph in Chile, they measured these subtle wobbles, just a few miles per hour. This Doppler effect is like the change in pitch of a passing siren. After years of data, the team announced their discovery in August 2016. The signal repeated every 11.2 Earth days, revealing Proxima B's year. The size of the wobble suggested a planet about 1.3 times Earth's mass, a rocky, terrestrial world. This wasn't a single eureka moment, but the result of years of patient, meticulous science. The universe suddenly felt a little less lonely. We've found thousands of exoplanets orbiting distant stars, each with its own unique story and mysteries. But among this vast cosmic menagerie, one world stands out. So why is Proxima B special? First, its proximity. At just over 4 light-years away, it's the closest known exoplanet to Earth. This makes it our best candidate for close-up study, and maybe even a robotic mission within a human lifetime. The dream of interstellar exploration feels a little less distant with Proxima B as our target. Second, its mass. Proxima B is likely a rocky, Earth-like world, not a gas giant. Its size and composition suggest a planet with a solid surface. Terrestrial planets can have solid surfaces, active geology, and possibly water and atmospheres, key ingredients for life as we understand it. These features make it a prime candidate in the search for habitability. Most exciting is its location in its star's habitable zone, a region where conditions might be just right for life to emerge. Proxima B orbits in the so-called habitable zone, where temperatures could allow liquid water to exist on its surface if the conditions are right. The Goldilocks zone is not too hot, not too cold, just right for life as we know it. This is the sweet spot astronomers are always searching for. Proxima B orbits much closer to its star than Earth does to the Sun, but because Proxima Centauri is a cool red dwarf, its habitable zone is much closer in. So we have a rocky, Earth-sized planet in our cosmic neighborhood in the habitable zone, a rare and remarkable combination. This makes Proxima B a world of profound significance, a tangible target for study and imagination and a symbol of our quest to find other Earths. It challenges the idea that Earth's conditions are unique, suggesting that potentially habitable worlds may be more common than we once thought. Proxima B is a scientific jackpot, inviting us to ask the biggest questions about life in the universe and pushing the boundaries of our technology and imagination. It's a cosmic invitation to look closer, to dream bigger, and to wonder what other secrets the universe might hold. The habitable zone doesn't guarantee a paradise, just the potential for liquid water. Proxima B offers both hope and challenge. Its location means, with the right atmosphere, it could have oceans or lakes. Its mass suggests it could hold onto an atmosphere and water. Red dwarfs, like Proxima Centauri, live for trillions of years, offering a long window for life to emerge. But Proxima Centauri is a flare star, unleashing violent radiation that could strip away a planet's atmosphere and sterilize its surface. Another challenge: tidal locking. One side of Proxima B may face eternal day, the other endless night. The only potentially habitable region might be the twilight terminator zone between the two extremes. So, is Proxima B a cradle for life or a cosmic death trap? The truth is, we just don't know yet. The paradox makes it one of the most intriguing worlds we've ever found. Imagine standing on Proxima B. The sky would be dim, bathed in reddish twilight, with Proxima Centauri looming large. The light would be faint and red, casting the landscape in crimson hues. Plants, if they exist, might be black or purple to absorb the star's low-energy light. A year on Proxima B is just 11.2 Earth days. Birthdays come fast. If tidally locked, one side bakes in endless daylight, the other freezes in darkness. Ferocious winds could rage between the two, creating a permanent storm system. Gravity would be stronger than Earth's. You'd feel heavier. Every aspect of life, light, weather, time, would be shaped by its red dwarf star. Proxima B is Earth-like in size, but profoundly alien in experience. It's a stark reminder: Earth-like doesn't mean Earth twin. The details of existence there would be utterly foreign. It's a world both familiar and strange. Suppose we could reach Proxima B. Could we survive? We don't know if it has an atmosphere. Stellar flares may have stripped it away. If it does, it could be toxic or unbreathable, like Venus or Mars. Creating a breathable environment would require advanced terraforming far beyond our current tech. Radiation is a huge threat. Constant flares mean any habitat would need heavy shielding, likely underground. Water is another unknown. The planet could be bone dry, or all its water might be frozen on the dark side. Managing water and food would demand closed-loop life support systems on a scale we've never attempted. The geology could be hazardous, and unknown microbes could pose risks to humans, or vice versa. Every challenge, from air to water to biology, would test our ingenuity and ethics. The dream of a new home is a complex, daunting puzzle. Proxima B would push humanity to its limits. Before we can worry about surviving on Proxima B, we have to get there. It's 424 light-years away, about 40 trillion kilometers. At current spacecraft speeds, the trip would take tens of thousands of years. To make it in a human lifetime, we'd need to travel at a significant fraction of light speed. Concepts like fusion rockets, antimatter engines, or laser-driven sails are still science fiction. The Breakthrough Starshot project aims to send tiny probes at 20% light speed, reaching Proxima Centauri in 20 years, but only for robots. At such speeds, even dust grains become deadly projectiles, and cosmic radiation is a constant threat. Shielding and life support would need to be revolutionary. The psychological challenge of a decades-long isolated journey is immense. Generations might live and die aboard a ship before arrival. The journey to Proxima B is as daunting as the destination. Why bother with Proxima B given the challenges? Because its scientific value is immense. It's our closest lab for studying planets beyond the solar system. Proxima B lets us test theories of planet formation, atmospheres, and habitability around red dwarfs. It's a chance to search for biosignatures, chemical hints of life, in a nearby world. New telescopes may soon let us analyze its atmosphere for oxygen, methane, or ozone. Studying Proxima B helps us understand our own planet and fuels innovation in technology. The quest is about understanding our origins and our place in the cosmos. Curiosity drives us to look beyond, just as it always has. Proxima Centauri B is more than a planet. It's a new frontier, a beacon calling us to explore beyond the familiar boundaries of our solar system. Its discovery has transformed interstellar travel from fantasy to a tangible goal, igniting imaginations and fueling new ambitions for humanity's future among the stars. It inspires scientists, engineers, and dreamers to push boundaries, to ask bold questions, and to design technologies that once seemed impossible. Whether we send nanocraft racing through the void, or build powerful telescopes to peer across light years, Proxima B gives us a reason to reach for the stars and imagine what lies beyond. It's a practice run for humanity's future beyond Earth, a proving ground for the skills, courage, and innovation we'll need to survive and thrive far from home. The challenges we face, radiation, life support, propulsion, are the same ones we must solve to survive in space, and each step forward brings us closer to overcoming them. Proxima B may not be our next home, but it's a crucial step in our journey, a stepping stone toward worlds yet to be discovered. As of today, it remains a world of mystery and promise, a dim, reddish point in our cosmic neighborhood, waiting for us to unlock its secrets. It challenges us, fuels our curiosity, and dares us to dream bigger than ever before, inspiring new generations to look up and wonder. The universe is vast, and our greatest adventures may still lie ahead, waiting for those bold enough to seek them. Proxima B is not just a destination, it's the beginning of a new chapter in our cosmic story, a symbol of hope and possibility for all of humanity. The night sky is a vast, open book, filled with stories of stars and worlds beyond our own. Each twinkling point is a chapter, a mystery waiting to be unraveled, and for centuries, humanity has gazed upward, searching for meaning in the darkness. For most of history, we only glimpsed our solar system, our celestial family. The planets and moons we could see were our only companions, and the rest of the universe seemed impossibly distant, unreachable. But we always wondered, are we alone? Is there life beyond the familiar orbs that circle our sun? Or are we the only ones to ponder the cosmos? Could there be other worlds orbiting other suns? Planets with oceans, mountains, and perhaps even life hidden in the glow of distant stars. The universe is immense, and the odds seem to favor other planets, maybe even ones like Earth. With billions of stars in our galaxy alone, the possibility of other Earths became more than just a dream. It became a scientific pursuit. This question drove us to build better telescopes and peer deeper into the cosmos. Each new instrument brought us closer to answers, revealing more of the universe's secrets. We searched for a reflection of ourselves, a second pale blue dot, something to remind us that we are not unique, that our story might be echoed elsewhere. This search is about more than rocks in space. It's about meaning and our place in the universe. It's about the hope that we are part of something larger, a cosmic community waiting to be discovered. We are explorers by nature, and the cosmos is our final frontier. The urge to venture beyond our world is woven into our DNA, driving us to seek out the unknown. Imagine looking up at the stars and realizing one of those points of light is actually three: the Alpha Centauri system, our closest stellar neighbors, shining just beyond our reach. This triple star system, just a cosmic stone's throw away, became a prime target for our search. Its proximity made it a beacon of possibility, a place where new worlds might be found. For years we wondered what might orbit those stars. Were there planets circling these suns, and if so, could any of them harbor life? Then, in 2016, we found something extraordinary. The news electrified the scientific community and captured imaginations around the world. Orbiting the faint, red dwarf Proxima Centauri, we detected a planet. Proxima Centauri B. It was a discovery that changed everything. This was the closest exoplanet ever found, just 4.2 light-years away. Suddenly the dream of reaching another world felt a little less impossible. The universe had whispered a secret, inviting us to explore. It was as if the cosmos itself was encouraging us to take the next step. The story of our search for other worlds had a thrilling new chapter. the discovery of Proxima Centauri B reignited our curiosity and hope. For the first time, another potentially habitable world was within reach. The possibility of life beyond Earth became more tangible than ever before. Our cosmic neighborhood suddenly felt a little less lonely. The universe, once so vast and empty, now seemed filled with new promise, and so began our quest to understand this new neighbor. The journey to Proxima Centauri B is just beginning, and with it, our story as explorers of the cosmos continues to unfold. What is Proxima Centauri B like? This question has intrigued scientists and space enthusiasts alike since its discovery. It's a super-Earth, slightly more massive than our own planet. This extra mass suggests a stronger gravitational pull, which could affect its atmosphere and potential for life. This means it's likely rocky, with a solid surface, crucial for life, as we know it. A solid surface provides a stable environment where life could potentially develop. Its discovery was a monumental step in our search for habitable worlds. It opened up new possibilities and questions about the universe. Proxima B orbits its star incredibly close, completing a year in just over 11 Earth days. This proximity to its star means it receives a significant amount of radiation. This places it in the habitable zone, the Goldilocks region where liquid water could exist. Water is essential for life, making this zone particularly interesting. Where there's water, there's the possibility of life. This simple fact drives much of our exploration and study of exoplanets. But there's a twist. Proxima B is probably tidally locked, with one side in perpetual daylight and the other in endless night. This creates extreme conditions on both sides. Between these extremes lies the Terminator Zone, a band of eternal sunrise or sunset, where temperatures might be just right. This zone could be a haven for life. This creates a world utterly alien to our own, with wild weather and a sky dominated by a dim, red sun. The unique conditions could lead to fascinating weather patterns. Permanent storms could rage on the dayside, while fierce winds whip between hot and cold. These winds could transport heat and potentially create habitable microenvironments. The planet is a place of stark contrasts: fire and ice, light and darkness. These extremes make it a challenging but fascinating subject of study. Understanding this environment is our first step in asking, could anything call it home? The potential for life in such a unique setting is a tantalizing mystery. The Terminator Zone may be the most promising region for habitability. Here conditions might be stable enough to support life. Here life could find a foothold in a world of endless twilight. The constant twilight could provide a stable environment for life to thrive. Proxima B challenges our imagination and our science. It pushes the boundaries of what we consider habitable. It's a world that forces us to rethink what it means to be habitable. The unique conditions on Proxima B could redefine our understanding of life-supporting environments. The more we learn, the more intriguing it becomes. Each discovery brings new questions and possibilities. Our nearest exoplanetary cousin is a mystery waiting to be solved. Its secrets could change our understanding of the universe. For a planet to be habitable, it needs more than a solid surface and the right temperature. It needs an atmosphere. This invisible shield is essential for life as we know it, acting as both a protective blanket and a chemical reservoir. An atmosphere traps heat, distributes it and provides pressure for liquid water. It also protects the surface from harmful radiation and cosmic impacts, creating a stable environment where life can potentially thrive. Without one, Proxima B would be a barren, airless rock, lifeless and exposed to the harshness of space, much like our own moon or Mercury. But Proxima Centauri is a volatile red dwarf, unleashing powerful flares that could strip away a planet's atmosphere in violent bursts, making survival even more challenging. If Proxima B has a strong magnetic field or a thick atmosphere, it might have survived this onslaught. These defenses could shield the planet, preserving its precious gases against the star's relentless assault. Volcanic activity could also help replenish lost gases, constantly renewing the atmosphere and giving the planet another chance at habitability. The fate of Proxima B's atmosphere hangs in a delicate balance between the star's fury and the planet's resilience, a cosmic tug-of-war that will determine its destiny. Scientists use telescopes like James Webb to search for clues, analyzing starlight passing through the planet's edge, hoping to catch the faintest hint of an atmosphere. If an atmosphere exists, it will leave a chemical fingerprint in the light, revealing its secrets through subtle patterns and colors. Finding any trace of atmosphere would be a monumental discovery, reshaping our understanding of what worlds might be capable of supporting life. It would bring us closer to knowing if Proxima B could be a living world, and perhaps, if we are not alone, in the universe. The search continues, one spectrum at a time, as we listen for the faint whispers of an atmosphere across the vastness of space. Suppose Proxima B has an atmosphere. What would it be like to breathe there? Earth's air is a unique blend, shaped by life and geology over billions of years. Proxima B's air could be very different, perhaps rich in carbon dioxide from volcanic activity, or even dominated by hydrogen and helium. A thick carbon dioxide atmosphere would be unbreathable and could create a scorching greenhouse effect. A hydrogen-rich atmosphere would be even more alien, affecting climate and chemistry in ways we're only beginning to understand. The most exciting possibility is the detection of biosignatures, gases like oxygen or methane that could hint at life. On Earth, oxygen is a product of life. Finding it on Proxima B would be a powerful, though not definitive sign of something alive. The breath of a world could be the whisper that we are not alone. This is the ultimate goal of our atmospheric studies. Life as we know it needs water. Water is the universal solvent, the medium for life's chemistry. Proxima B's place in the habitable zone means liquid water is possible if it has a substantial atmosphere. On a tidally locked world, water might boil away on the hot side and freeze on the dark side. The terminator zone, in perpetual twilight, could be mild enough for oceans or lakes. Imagine a world of endless sunset, bathed in a dim, reddish glow. Detecting water is a challenge. We can't see Proxima B directly. Instead, we search for water vapor in its atmosphere, using telescopes like James Webb. Water vapor would be a strong indicator of a water cycle and surface liquid. Future telescopes might even spot the glint of alien oceans. Finding water would be a signpost on our journey to find life. Why is water so special? Its unique properties make it the key to life. Water moderates temperature, helping transport heat across a planet. On Proxima B, oceans could help make more of the surface habitable. Ice floats, insulating life below, and preventing oceans from freezing solid. Water's role as a universal solvent allows vital molecules to move and interact. Without water, life's chemistry would grind to a halt. Any life on Proxima B would almost certainly need a liquid like water. While exotic chemistries are possible, water-based life is what we know. Finding a world with liquid water means finding a familiar signpost in the cosmos. It tells us we're on the right path. The search for water is the search for a second Genesis. Living near a red dwarf like Proxima Centauri is both a blessing and a curse. Its long life could give life time to evolve, but its violent flares are a constant threat. Proxima B is bombarded by intense radiation, dangerous for life and destructive to atmospheres. Any life would need protection. A strong magnetic field, a thick atmosphere, or perhaps a refuge underwater. Water is an excellent shield against radiation. Life could thrive in deep oceans, far from the star's fury. The surface might be lifeless, but the depths could hide a thriving biosphere. On Earth, life flourishes around hydrothermal vents in the deep sea. Proxima B could host similar hidden ecosystems. The challenge is surviving the star's fiery embrace. But where there's water and protection, life finds a way. If humans ever travel to Proxima B, we'll face the same dangers: radiation, extreme temperatures, and a hostile environment. We'd need to build underground habitats shielded by rock and soil. These bases would be self-sufficient, recycling air, water, and waste. Food could be grown with hydroponics under artificial lights. Power might come from solar panels, geothermal, or nuclear sources. Exploration would require advanced rovers and spacesuits built to withstand radiation and thin air. Every step outside would be a carefully planned risk. The journey to Proxima B would take decades or centuries. The psychological toll of living underground, under a red sun, would be immense. But humanity is defined by overcoming challenges. The dream of living on another world drives us to innovate. Today, Proxima Centauri B is still just a wobble in a distant star's light, but it's also a symbol of hope. It's transformed the search for life from a dream into a tangible goal. Every new discovery brings this alien world into sharper focus. The coming decades will be a golden age of exoplanet exploration. We'll map its climate, study its atmosphere, and search for signs of water and life. Even microbial life would be a profound discovery, proving we're not alone. Projects like Breakthrough Starshot aim to send probes to Alpha Centauri within a human lifetime. It's the first step on a long journey, one that may see our descendants look up at a red sun in an alien sky. The cosmos awaits. Our story among the stars is just beginning. For as long as we have looked up, we have wondered, are we alone? Is there another world out there like ours? Today, science has given us a destination, a small, rocky world orbiting the very nearest star to our sun, Proxima Centauri B, just 4 light-years away. It's a cosmic stone's throw, yet represents the greatest journey humanity has ever imagined. Discovered in 2016, Proxima B is a super-Earth, slightly more massive than our planet, orbiting in the habitable zone, the Goldilocks region where liquid water could exist. Where there is water, there could be life. This possibility calls us to a new age of exploration, but Proxima Centauri is a red dwarf, small, faint, and temperamental, unleashing powerful flares and deadly radiation. Proxima B is a world of extremes. One side may be locked in daylight, the other in endless night. The challenges are immense, but so is our drive to explore. We are descendants of voyagers who crossed oceans and continents, always seeking what lies beyond the horizon. Now, the horizon is another star system. The journey to Proxima B is more than a technological challenge. It's a test of our spirit and ingenuity. It forces us to ask, what does it mean to leave our homeworld behind? How would we build a new society on an alien shore? This quest is more than a scientific mission. It's the next chapter in humanity's epic story, a story written among the stars. It's a journey into the unknown, to discover a new world, and perhaps our own future. The pull of exploration is in our nature. Proxima B is the next great ocean we must cross. The adventure begins with a single question. Are we ready to answer the call? How do you travel to a star? Our fastest spacecraft would take tens of thousands of years to reach Proxima Centauri. Clearly, we need a new kind of ship. The answer may lie in something much smaller, nanocraft, tiny probes, no bigger than a postage stamp. These starships of the future would be propelled not by fuel, but by light. On Earth, we'd build a colossal laser array, a light beamer, to focus immense energy onto each nanocraft's reflective light sail. The laser's photons push the sail, accelerating the craft to incredible speeds. We're talking up to 20% the speed of light, over 100 million miles per hour. At that velocity, the journey to Proxima Centauri would take just 20 years. The first explorers would be robotic, sending back images and data, paving the way for humans. The engineering challenges are enormous, building the most powerful laser array ever, designing ultralight, resilient sails, and figuring out how to slow down at the destination. But the concept, riding on a beam of light, is grounded in physics we understand today. It's our most realistic pathway to the stars. These nanocraft would be our eyes and ears, the vanguard of interstellar exploration. Their success would mark humanity's first step beyond the solar system. The dream of reaching another star is no longer science fiction. It's a challenge for engineers, physicists, and dreamers alike. The journey begins with a spark of light, and with it, we send our curiosity across the void. The age of interstellar travel could begin with a fleet of tiny sails. The stars are within reach, if we dare to chase them. After robotic scouts map the way, humanity will follow, but not on nanocraft. We'll need a world ship, a self-contained ecosystem, a miniature Earth hurtling through space. This ark must shield its crew from radiation, recycle every resource, and sustain life for decades. Propulsion, for such a massive ship, will likely come from fusion rockets, harnessing the energy of the stars. By fusing elements like deuterium and helium-3, these engines could provide continuous thrust, making a human mission possible within a lifetime. Inside, life would be a delicate balance, closed-loop systems for air, water, and food, with hydroponic farms and advanced recycling. The crew would be farmers, engineers, and caretakers of their own tiny world. Psychological challenges would be immense. The ship's interior would mimic natural environments with communal spaces for art, music, and recreation. The Earth would shrink to a pale blue dot, then disappear. This world ship would be a society in miniature, carrying humanity's culture and knowledge across the stars. It would be a fragile candle of consciousness on its way to a new sun. The dream of interstellar travel would become a reality. One ship, one journey, one future. Arriving at Proxima B is just the beginning. The first habitats will be underground, shielded from deadly radiation by the planet's crust. Modular, expandable tunnels, built by robots using local materials, will form the backbone of the colony. Structures will be 3D printed from regolith, reducing the need to bring materials from Earth. Power will come from compact nuclear reactors, providing reliable energy for life support, lighting, and exploration. Inside, life will blend the familiar and the alien pressurized habitats, artificial day-night cycles, and hydroponic farms. The view will be of rocky caverns, not blue skies. Colonists will live in a meticulously controlled bubble, a machine, a fortress, a sanctuary. Every resource will be precious, every system vital. This will be humanity's first outpost in a new solar system. What would it be like to stand on Proxima B? The sky would glow orange or deep red, not blue. If tidally locked, one side faces eternal day, the other endless night. The Terminator Zone, a band of perpetual twilight, offers the best hope for life and habitability. Here, temperatures might allow liquid water, and rivers could flow under a dim red sky. Earth plants would need genetic engineering to thrive under red light, or we might find native life with black or purple foliage. Solar flares mean intense radiation. Spacesuits and rovers must be heavily shielded. The Terminator Zone would be a world of long shadows and strange light. Every step would remind us how far we are from home. Exploring Proxima B would challenge our senses and our technology. It would be a landscape both beautiful and alien. The first question: what's in the air? Proxima B's atmosphere will shape the colony's future. It's unlikely to be Earth-like, more probably thick with carbon dioxide, thin like Mars, or even toxic. Early settlers will live inside habitats, breathing manufactured air. The long-term dream is terraforming, engineering the planet to be more like Earth. Genetically engineered microbes could slowly convert carbon dioxide to oxygen, a process taking centuries. Water is crucial. Probes will search for ice or vapor to harvest for drinking, farming, and air production. Atmospheric pressure is another challenge. Too low or too high, and survival is impossible without suits. Terraforming would mean adjusting atmospheric density, releasing or trapping gases as needed. Breathing Proxima B's air unaided is a distant goal, requiring generations of effort. It's the ultimate act of planetary engineering. The dream, to one day walk outside and breathe freely under a red sun. As we try to change Proxima B, it will change us. Higher gravity will strain our bodies, denser bones, stronger muscles, and robust hearts may evolve over generations. Colonists may experience fatigue and joint pain, but future generations will adapt. Radiation from Proxima Centauri's flares is a constant threat. Gene editing could enhance our DNA repair. Borrowing from radiation-resistant organisms, our senses may change too, eyes evolving to see better in red and infrared light. These adaptations, both engineered and natural, would create a new kind of human. Life on Proxima B would be a full-body challenge, shaping us in ways we can only imagine. The first generation would struggle, but their descendants would thrive. We would become a people built for a new world. The story of humanity would branch in a new direction. Evolution would continue, under a different sun. Separation from Earth would create a distinct society on Proxima B. New culture, values, and even biology. With a 20-year communication delay, colonists must be self-reliant, developing their own governance, art, and identity. Over generations, higher gravity and radiation would drive physical changes. Shorter, stockier builds, new skin pigmentation. This is a new branch of the human evolutionary tree, perhaps Homo proximan. Earth would become a legend, a distant origin story. The process of speciation would play out across the stars. Colonizing Proxima B safeguards the future of consciousness, a second basket for humanity's eggs. Should disaster strike Earth, our legacy would live on under a different sun. This new humanity might one day launch their own starships, continuing the chain of exploration. The story of life would expand, written on new worlds. The journey to Proxima Centauri B is the grandest adventure we can imagine. It demands breakthroughs in propulsion, energy, life support, and genetics, and unprecedented cooperation. But exploration is in our DNA. Colonizing another planet would transform humanity's perspective, making us a truly cosmic species. The divisions of today would seem small against the backdrop of interstellar colonization. the mission would inspire new generations and drive technological advances that benefit Earth. The quest for Proxima B would teach us to value our own planet even more. In the vast cosmos, Earth is a fragile island of life. We may not know if we're alone, but we have the power to find out. Sending ourselves into the darkness is an investment in our survival. It's the next step in our evolution, our chance to step off our planetary cradle and into the universe. Perhaps, it is our ultimate destiny. For millennia, humanity has gazed at the stars, our imaginations ignited by the mysteries shimmering above us, from ancient storytellers weaving legends about constellations, to philosophers pondering our place in the universe. The night sky has always inspired wonder and curiosity. We have always wondered what lies beyond our blue world, what secrets are hidden in the vast darkness, and whether we are truly alone in the cosmos. Today, that ancient curiosity is transforming into a real quest. No longer content to simply observe, we are building the tools and technology to explore the cosmos firsthand, to reach out and touch the unknown. Among the countless worlds we've discovered, one stands out: Proxima Centauri B, a rocky planet orbiting the closest star to our Sun. It sits just over 4 light-years away, tantalizingly close in cosmic terms, yet still unimaginably distant for us. The idea of reaching Proxima Centauri B is more than a scientific milestone. It's a symbol of our drive to explore, to survive, and to push the boundaries of what's possible. It represents our hope for a future where humanity is not confined to a single planet. This journey challenges us to build ships that can cross the vast gulf of interstellar space, enduring journeys that could last generations, and to invent new ways of traveling faster and farther than ever before. It asks us to imagine and create societies that can endure centuries in isolation, thriving in the darkness between stars, carrying our culture and dreams with them. Scientists and engineers are already piecing together clues about this distant world, asking, could it have water? An atmosphere? Could it support life as we know it, or something entirely alien? While the technology to get there is still in its infancy, the dream is alive, fueled by new telescopes, bold designs, and the relentless pursuit of knowledge. Each discovery brings us a step closer to making interstellar travel a reality. The public's excitement grows with every new mission, every rocket launch, and every glimpse of a possible new world. People everywhere are eager for humanity's next giant leap. The story of Proxima Centauri B is ultimately about us, our audacity to dream, our willingness to face the unknown, and our unbreakable spirit of exploration. It is a testament to our determination to make those dreams real, to reach for the stars, and to ensure that the story of humanity continues, wherever it may lead. Proxima Centauri B's allure begins with its location, orbiting the nearest star system, just 4.24 light-years away. It sits in the habitable zone, the region where temperatures could allow liquid water to exist. This Goldilocks zone makes it a prime candidate for life, as we know it. But life around a red dwarf like Proxima Centauri would be very different from Earth. The planet's year lasts just 11 days and it's likely tidally locked, one side in perpetual day, the other in endless night. Red dwarfs are volatile, unleashing flares that could strip away atmospheres and bombard the surface with radiation. Despite these challenges, Proxima Centauri B remains our closest laboratory for studying alien worlds. Each new discovery, from the James Webb Space Telescope to hints of planets around Alpha Centauri, adds to our understanding. Proxima Centauri B is where we test our theories of habitability and imagine our future among the stars. Reaching Proxima Centauri B isn't a quick trip. It's a journey that could span centuries, requiring not just advanced technology but also a profound commitment to the future. Enter the concept of the generation ship, a self-sustaining ark where entire communities live, work, and die en route to another star. These ships are designed to be miniature worlds, complete with everything needed to sustain life for multiple generations. The Chrysalis, a recent award-winning design, envisions a rotating city-sized spacecraft supporting 2,400 people for a 400-year voyage. This ship is a marvel of engineering, designed to create a stable and sustainable environment for its inhabitants. Artificial gravity, closed-loop ecosystems, and vast agricultural zones would keep the crew healthy and fed. These systems are crucial for maintaining a balanced and self-sufficient habitat. Livestock, forests, and streams would provide not just sustenance but a vital, psychological link to Earth. These natural elements help maintain mental well-being and a sense of connection to our home planet. The ship's society would blend humans, advanced robots, and AI, working together to solve problems and make decisions. This collaboration is essential for the smooth operation of the ship and the success of the mission. The real challenge isn't just technical, it's social, preserving knowledge, culture, and purpose across generations. Ensuring that each new generation understands and embraces the mission is crucial for the continuity of the journey. The chrysalis is more than a machine. It's a vessel for civilization, carrying our hopes to a new world. It represents humanity's enduring spirit and our quest to explore the unknown. Those who arrive will be the descendants of those who left, inheriting a mission centuries in the making. They will carry forward the dreams and aspirations of their ancestors. The generation ship is humanity's boldest answer to the vastness of interstellar space, a testament to our ingenuity and determination to reach the stars. The greatest obstacle to Proxima Centauri B is distance. 40 trillion kilometers of empty space. A journey lasting centuries demands a ship that can operate flawlessly, with every system repairable by its crew. Even a single critical failure could doom the mission. The human challenge is just as daunting. How do you maintain purpose and cohesion in a society isolated for generations? Later generations will know only the ship, their destination a story passed down through time. Cosmic radiation, micrometeoroids, and the relentless void make the ship both sanctuary and fortress. The journey is a test of endurance, technological, social, and psychological, unlike anything humanity has ever faced. It's not just a trip, it's a centuries-long struggle for survival and meaning. Arrival at Proxima Centauri B marks a new beginning, not the end. The planet's surface will likely be hostile. Colonists must build secure, self-sustaining habitats, probably underground or heavily shielded. Advanced robotics and tunneling machines will be essential for constructing these first shelters. Power will come from nuclear reactors or solar arrays, especially on the planet's perpetual day side. Life support systems, perfected over centuries, will recycle air and water with extreme efficiency. Every resource will be precious. Waste is not an option. The initial settlement is a closed-loop ecosystem, a larger version of the generation ship. Long-term, the dream is terraforming, altering the planet to make it more Earth-like, a project for future generations. The first habitat is the seed of a new civilization, proof of humanity's ability to adapt and endure. Survival on Proxima Centauri B depends on mastering closed ecosystems. Colonists must grow all their own food. Hydroponics and aeroponics will be the backbone of agriculture. Crops will be genetically engineered for nutrition, speed, and resilience, grown under artificial light. Plants will not only feed people but also recycle air, forming a symbiotic system. Insects and aquaculture will provide efficient protein sources, with waste from one system feeding another. Lab-grown meat could add variety and comfort. AI will monitor every aspect of the ecosystem, catching problems before they become crises. Colonists are not just farmers, they're ecosystem engineers, balancing a delicate web of life. Their survival depends on precision, innovation, and constant vigilance. The mental challenge of a centuries-long journey is immense. Confinement, isolation, and the knowledge of being alone in a star system can weigh heavily on the mind. The ship must foster purpose, community, and resilience through virtual reality, communal spaces, and meaningful work. Social structures, conflict resolution, and mental health support are essential to prevent breakdown. Upon arrival, the stress shifts to survival in a hostile world, with the burden of being humanity's only outpost. Building psychological strength and a shared identity will be as vital as any technology. Our journey to Proxima Centauri B begins with telescopes, our eyes on the cosmos. Discoveries by the James Webb Space Telescope and others have revolutionized our understanding of nearby exoplanets. Each observation, whether confirming or refuting, sharpens our models and guides future missions. The upcoming Nancy Grace Roman Space Telescope will expand our search, using advanced technology to directly image exoplanets. These missions transform Proxima Centauri B from a distant idea into a real place we can study and plan for. Theoretical work, like the Chrysalis generation ship, pushes engineers to solve the challenges of interstellar travel. This synergy between observation and innovation is paving the road to the stars. Every new discovery brings us closer to turning science fiction into reality. The groundwork we lay today will shape humanity's future among the stars. The quest for Proxima Centauri B is about more than science, it's about the future of humanity. It represents our deepest hopes and our willingness to face the unknown, driven by curiosity and the desire to secure our place in the universe. Our drive to explore and survive has always pushed us into the unknown. Reaching another star is the next great leap. For generations we've looked up at the night sky and wondered what lies beyond. Now we have the chance to turn those dreams into reality. Becoming an interstellar species is the ultimate insurance policy against catastrophe on Earth. Whether it's natural disasters, climate change, or threats from space, having a foothold beyond our home planet could one day mean the survival of our species. A self-sufficient outpost on another world would ensure our story continues, no matter what happens here. It would be a new chapter for humanity, a chance to build societies from the ground up and learn from our past. The technologies we develop for this journey, recycling, energy, food, will transform life on Earth as well. Innovations born from necessity in space could help solve some of our biggest challenges at home, making our world more sustainable and efficient. The challenge of survival in space will teach us lessons in sustainability and resilience. Every resource will matter, and every solution will count, pushing us to become better stewards of our own planet. The dream of Proxima Centauri B unites us, inspiring innovation and cooperation across borders. It brings together people of all backgrounds, working side by side to achieve something greater than any one nation or generation could accomplish alone. Whether or not we reach it soon, the journey has already begun in our minds and laboratories. Every experiment, every prototype, and every new idea brings us one step closer to the stars. It's a testament to our spirit, to dream, to explore, and to reach for a future beyond our present. Our determination to go further is what defines us as a species. This may be the most important journey humanity will ever undertake. A journey that could redefine who we are and what we are capable of achieving together.